Today, I will explain to you the working principle of IGBT. The IGBT is a three-terminal device: gate, G, collector, C, and emitter, E. The three terminals of the IGBT are connected to the metal conductive layer usually made of aluminum. The aluminum conductive layer on the gate is insulated by a silicon dioxide layer. Inside the IGBT is a collector composed of 4 layers of semiconductor material. The first layer on the collector is the substrate with holes carriers. It's also called the injection layer. The main function is to inject holes into the next N-type semiconductor drift layer. The meaning of the negative drift layer is that when in the conducting state, there are 2 kinds of carriers in this layer: holes carriers and free electrons. The majority of carriers are free electrons. The drift layer is thick, low doping concentration. Therefore, the resistivity of the negative drift layer is extremely high. The thickness of the drift region determines the voltage blocking ability of the IGBT. Above the drift area is the body area, consists of P-type semiconductor composition. It is close to the emitter. There is an N-type semiconductor layer with hole carriers inside the body region. The IGBT equivalent diagram is shown in the figure. This forms a PNP transistor on the outside of semiconductor region. Create the transistor PN junction between collector and drift region, we call it J2. PN junction between the N region and the housing, we call it J1. We can think of an IGBT as a Darlington transistor composed of an N-channel MOSFET and PNP type BJT. The resistance in the diagram represents the resistance of the drift region from the above structure. We can see that there is more than one channel for forming current. The first path is a current collector, a substrate, a negative drift layer, and a P-type semiconductor emitter. This is the main channel of the working current. The second path is the collector P plus substrate, N drift layer, P-type semiconductor, N plus semiconductor emitter. When the collector is at positive voltage and the emitter is a negative voltage, J2 forms a forward bias and J1 forms a reverse bias. When no voltage is applied to the gate, due to J1 reverse bias, IGBT is turned off. No current flows between collector and emitter. When a positive voltage is applied to the gate with respect to the emitter, it creates a capacitive effect. A large number of negatively charged electrons are gathered under the silica, formed a chain passage. Increasing the gate voltage increases the number of electrons when the voltage is higher than the preset value, forming the carrier's current layer. This preset value is usually 4 to 8 volts. A channel is formed between this current layer and running drift layer, we call it in-channel. In this way, electrons from the emitter flows from the N plus region to the N negative drift layer. At the same time, hole carriers from P positive region injected into the N-type drift layer due to the existence of the N-type drift layer excess hole carriers with negatively charged free electrons. Because its conductivity has increased, causing the generation of electric current, so the IGBT is turned on. This is how IGBT works. Hope you understand it. Like, comment, share, and subscribe.